looking at light-emitting diodes. Light-emitting diode operates the same way as a normal diode in that current only flows in one direction, and with the symbol in the conventional current flow in the direction of the arrow. These two arrows indicate that light is coming out from the diode. There are different colored LEDs, the small signal diodes that we are using, or indicator diodes that we're using on this course, often have a colored plastic lens on them, which contributes to the color that they give off. However, there are some diodes, light-emitting diodes, that have a clear plastic lens, and the light they give off from their diode junction is of different colors. Now, light-emitting diodes are manufactured in such a way as they give off a certain color of light or a certain frequency of light when current passes through them. We can see from this diagram here that because light-emitting diodes only pass current in one direction, we need to know which way around in a circuit they are. Therefore, as with most semiconductors, if one leg is long, or components, any component, in fact, if one leg is longer than the other, that normally indicates that it is the positive or the anode part of the device, and the shorter one being the cathode. With light-emitting diodes as well, once the legs have been trimmed off, we wouldn't be able to work out which is which, and so these small light-emitting diodes normally have a flat portion on their base like this, which indicates the negative part of the light-emitting diode. Now, the frequency of light that light-emitting diode will give off ranges from infrared, where we can't see it, all the way up to white light that we can see it. And the difference between the diode is that depending on the frequency of light, depends on the forward voltage across the diode when it's conducting. So with the normal general purpose diode, we saw that they turned on and started conducting at about 0.6 to 0.7 of a volt. Light emitting diodes require a higher voltage to get current to flow, and it's often in the range of somewhere between 2 and 4 volts, depending on the color of the light that's given off. Although once again, the LEDs that have got the colored plastic lens on them all tend to be around about the 2 volt range, but the clear plastic ones that give off specific frequencies of light will vary quite dramatically, as they from the infrared diode here we can see is about 1 volt, and the white light one is nearly 5 volts that it gives off when it's conducting. The other thing we need to notice about light emitting diodes is that they are very current sensitive, and these small ones typically operate at around about 20 milliamps forward current, which means that when we put them in a circuit, we have to limit the voltage across them to their characteristic voltage and limit the current to about 20 milliamps. Therefore, in most circuits that we need, that we use LEDs in, we have to operate them with a current limiting resistor. And our job is to find out what is that value of current limiting resistor. So in this particular circuit, if we have a 5 volt input and we have a LED that when it's conducting drops 3 volts across it with 20 milliamps flowing through it, what is the value of the resistor required? So the value, the voltage across the resistor will be 5 minus 3 because it's a series circuit, and the current flowing through the resistor will be the same as the current flowing through the LED, 20 milliamps. So now we can very easily work out the value of the resistor in ohms. We could also work out the required power rating of the resistor, although with 20 milliamps and 100 ohms, it's going to be a low powered resistor. A quarter watt resistor would be more than sufficient. We might even get away with a smaller one. We could do that calculation if we wanted to. The data sheets for light emitting diodes are all fairly similar. One thing we do have to be aware of is the reverse voltage, and light emitting diodes don't like a high reverse voltage. Typically they can only handle around about 5 volts of reverse voltage before they are destroyed. So we have to be very careful that they're not put in a circuit where they're going to be subjected to a high reverse voltage. And again, typically their forward current is around about 20 milliamps, can handle up to about 30 occasionally, but in this particular case, the suggested current was about 16 to 18, would give us our maximum light output. 20 would be the nominal amount. So often if we're just, as a rule of thumb, we work out our value of our current limiting resistor, assuming around about 2 volts and 20 milliamps for our diode. Light emitting diodes come in different shapes and sizes. These small ones used as indicator lamps. We also now are aware, I'm sure, that we have LEDs used in high power consumptions, like this one up here is a downlights. These ones differ slightly from the little wee ones in that they actually do get quite hot when they're operating. Typically the junction gets up to about 400 degrees Celsius, although the junction is only about, or the piece of silicon that glows is only about 1 millimeter square, but it still needs some sort of heat sink on it to keep it cool, because they don't like excessive heat. So the uses of diodes, we use them in all sorts of situations, in cars and street lighting now and house lighting. So what the advantage of the LEDs is that they have a lot lower power consumption. They actually do generate overall a lot less heat. We can switch them on and off a lot faster than an incandescent bulb. They're quite robust because they don't have a filament that could be easily damaged, and they have because they don't get hot and are robust, they have actually a lot longer life than a normal incandescent bulb. And so they're becoming very, very popular because of their high efficiency, their low cost compared to how long they can last, and so they're seen as a lot more environmentally friendly. So in the circuits that we're going to be using on this course, we're just going to be using the little wee indicator lamps, in every circuit that we put it into, we have to be aware of what is the current limiting resistor required for the LEDs.